1.3 quadratic expressions and equations took a look at how we can work with expressions that have x squared in them and an x in them and what we can do with them. And the big thing we're going to take a look at first is this idea of factoring. And just as a quick review of factoring, the first thing you should always do when factoring any problem is look for the greatest common factor first. And then after we get that greatest common factor out of there, then we can look at factoring what's left based on if it has 4 terms, or if it has 2 terms, or if it has 3 terms. Because if it has 4 terms, we're generally going to use, if you remember, a grouping strategy, where we group the left and right sides and hopefully find a binomial GCF in the middle. If there were 2 terms, we had several special products that we could use. Difference of squares, sum and difference of cubes, the special products would help us continue to factor. 3 terms are probably the most memorable, where we use kind of that guess and check method of finding the best factors for the trinomial that we're working with. So let's take a look at some of these examples. First, just basically looking at the GCF example, because we should always do the greatest common factor first. Always. Every problem. Don't forget the GCF first. So if we've got a problem like 7a to the 3n minus 28, what you'll see is both 7 and 28 are divisible by 7, so we can factor that 7 out. And when we divide the 7 out of each term, we're left with a to the 3n minus 4 for our factored solution. Similarly, if I look at an example such as 3x to the 5n plus 12x to the 2n, you'll notice both of those factors, 3 and 12, are divisible by 3. In addition, though, they have several x's in common. When we want to know how many x's in common, we take the smallest exponent out, and 2n is smaller than 5n, so we'll take out 2n. And when we divide 3x to the 5n by 3x to the 2n, we're left with x to the 3n. Plus, 12 divided by 3 is 4, and the x to the 2n's are divided out. And we have now factored out that greatest common factor. Let's try one more GCF problem. Let's do 5x to the 2n, y to the 6n, minus 10x to the n, y to the 7n, plus 15x to the 6n, y to the n. With 3 terms, we see all 3 numbers, 5, 10, and 15, are all divisible by 5. So we're going to start by factoring out a 5. We also look at the x's, and we see that every single term has an x on it. In fact, they all have at least n of them. N is the smallest exponent. And on the y's, we see they all have at least n of them also, taking the smallest exponent, the x to the n and the y to the n. And then what's left after we divide out 5x to the n, y to the n, is going to go inside the parentheses. 5 divided by 5 is 1. X to the 2n divided by x to the n is x to the 1n. Y to the 6 minus 1 leaves behind 5n's. Minus 10 divided by 5 is 2. The x to the n divides out completely. We're left with y to the 6n. Plus 15 divided by 5 is 3. X to the 6 minus 1 leaves behind 5n's. And the y to the n is completely divided out. And we have our solution. So always remember, with factoring, we will always do that GCF, greatest common factor, first before we do any other type of factoring. Once we've done that, though, we have to decide how many terms I think we're on letter C, we have to decide how many terms are in the remaining expression. If there are 4 terms, we said we would use grouping, where we take the GCF out of the left and right sides. Again, as a reminder, we do this when there are 4 terms. And to kind of set up grouping, we're going to do a non-grouping example first, looking at x plus 3 times y minus 7 plus x plus 3 times y plus 2. And what we see in these two parts is both parts have an x plus 3 in common. That is the GCF, so we're going to factor it out as an x plus 3. Notice it did not come out as x plus 3 squared because there's 2 of them. Squared means we multiply them together. These are added together. These are factors that are pulled out. So we pull out a factor of x plus 3, leaving behind a y minus 7 plus a y plus 2. And we can simplify that last parentheses a bit by combining like terms. The x plus 3 is still there. We've got 2y's minus 9. Minus 7 plus 2 is 9. And we have now factored this expression. Now normally with grouping, though, we have to get it set up to be in that form that we want to work with. So we're normally going to have something like x squared y plus 2x squared minus 9y minus 18. And how grouping is going to work is we're going to split the expression in half with the 4 terms and factor the GCF out of the left and right sides. On the left side, we see a GCF of x squared, leaving behind y plus 2. On the right side, we see a GCF of negative 9, leaving behind y plus 2. And what makes this all work is that y plus 2 is a common factor on both. So we factor out that y plus 2, leaving behind the x squared minus 9. And this is a nice segue into our next topic because we're not done yet. X squared minus 9, you might remember, can factor further. We'll still have the y plus 2, but the x squared minus 9 is x plus 3 times x minus 3 to give us our final completely factored form. Let's look at that in more detail. That last step I did, the x squared minus 9. That is one of our special products that we talk about. Special products are generally what we look for when we have 2 terms. And there are 2 different types of special products, and the exponents are going to give away what we're talking about. The first type of special product is a difference of squares. A difference of squares is when we have something like a squared minus b squared, where we're subtracting 2 things that are squared. When we do subtract 2 things that are squared, it's going to come out to 2 binomials, where we take the square roots of both the first and the last, and one of them's a sum and one of them's a difference, and it doesn't matter which one. So plus or minus the square roots, basically. And it's really important for this to work, we need that minus sign. If it's a plus, you cannot factor it. But with a minus sign, you sure can factor it. So for example, if we had 36x to the 2n minus 25y to the 2n, we can take the square roots of both parts. The square root of 36 is 6. And the square root of x to the 2n is x to the n. Similarly, the square root of 25 is 5. And the square root of y to the 2n, square root divides the exponent by 2, is 5y. So when we factor to the n, sorry, 5y to the n, when we factor, it's going to factor to the sum and the difference of those square roots. So 6x to the n plus 5y to the n times 6x to the n minus 5y to the n. How about this one? Make it a little more interesting. We're going to say a plus 2 squared minus b plus 2 squared. Don't get thrown off by all the extra stuff. We are still subtracting two things that are squared. We are subtracting an a plus 2 and a b plus 2. So when it factors, it's going to factor to the sum and the difference of those square roots, a plus 2 and b plus 2. When we distribute the plus and minus through the parentheses, it'll even allow us to do a little simplifying. So we have a plus 2 plus b plus 2 after we distribute the plus. That's not going to change anything. We also have a plus 2. When we distribute the minus, it goes all the way through, minus b minus 2. And then when we combine like terms, we get a plus b plus 4 for the first factor, and a minus b for the second factor. And it is now completely factored. We can even do a combination of these two examples. We could do something like 16a to the 4th minus y plus 2x squared. Noticing the pattern and the structure of factoring here. We can take the square roots of both halves, and there's a minus in the middle. We can find the square root of 16 is 4. The square root of a to the 4th, dividing the exponent by 2, is a squared. The y plus 2x squared, the square root of that is simply y plus 2x in parentheses. And so to factor, we make it the sum and the difference of those square roots, 4a squared minus y plus 2x. And again, we'll simplify by distributing those negatives through and the positives through the parentheses. The positive's not going to do much excitement, so the first factor, 4a squared plus y plus 2x. The second factor, 4a squared minus y minus 2x. And we have our solution. So that's our first factoring special product. The second special product is not squares, but it is cubes. And we can do both sum and difference with cubes. You remember with squares it had to be a difference, it had to be subtraction. With cubes it can be either plus or minus, and both of them are really similar to each other. A cubed plus or minus b cubed is going to factor to a binomial and a trinomial. What I do is I take the cube roots of both parts. The cube roots of both parts are a and b. Then in the trinomial we square the first one, multiply them together, a, b, and square the last one. To fill in the signs, we do the same sign as the problem, the opposite sign of the problem, and then always plus. I think about the word soap. So the same sign will be either plus or minus. The opposite sign will be either minus or plus, because it's going to be opposite. And the last one's going to always be positive, always plus. So if we are asked to factor something like 27a cubed minus 64b cubed, what's going to clue us into this formula is we see all the exponents are cubed. So we take the cube roots. What to the third power is 27? 3. The cube root of a cubed is a. What to the third power is 64? 4. The cube root of b to the cubed is 4b. The second part, the trinomial, we square the first. So 3a squared is 9a squared. Multiply them together. 3 times 4 is 12, ab. And then square the last term. 4 squared is 16b squared. Then we use SOAP to help us decide the signs. Because S means same sign as the problem, minus in this case. O means opposite, plus. And AP is always positive. We have now factored that difference of cubes. A sum of cubes follows the exact same pattern. If we had 8b to the 3n plus c to the 6n, we see those exponents are multiples of 3. That's going to clue us in on the formula for sum and difference of cubes. The cube root of 8 is 2. The cube root of b to the 3n, dividing the exponent by 3, leaves us just b to the n. The cube root of 6c to the 6n, divide the exponent by 3, leaves behind 2n. And then in the trinomial, we square the first. 2 squared is 4. B to the n squared is b to the 2n. Multiply them together, so we have 2b to the n, c to the 2n. And then we square the last one, which is c to the 4n, squaring, multiplying the exponent by 2. And then again, we think SOAP to help us with the signs. Same sign as the problem would be a plus, opposite sign minus, and then always plus for the last sign. We have now factored this difference of cubes. Sorry, sum of cubes. So with 4 terms, we use grouping. With 2 terms, we use the special products. With 3 terms, though, that's the one that gets the most attention. That is our guess and check method with 3 terms. And to set this up, we'll remember that we have a plus b times c plus d. And if we multiply it out, we would do a times c to get ac, a times d to get plus ad, b times c to get bc, and finally b times d to get bd. And kind of what makes it all work and come together as we're factoring is the first term times the first term equals the first term. First times first equals first. We're going to use that to help us guess what the first term should be in each factor. Similarly, you'll notice that b times d, the last times the last, equals the last term. We'll use that to guess what the last terms in each factor are, and then all we have to do is simply check. That was a bad bracket. We're going to check the middle part to make sure that it works. So if I have 6x squared plus 7x minus 20, and we're going to guess and check our way to the binomial factors that make this up, we would look first at the 6x squared. First times first has to equal first. What's a way we can multiply to 6x squared? Well, one guess might be 2x and 3x. Then the last term, negative 20, last times last has to equal 20. One guess might be 5 and 4. Then what I will do is I will check the middle stuff. And the way we check the middle stuff is we multiply the greens and pinks together, if you will. The outside, 2x times 4 is 8x. The inside, 5 times 3 is 15x. Can we use 8x and 15x to get the 7x in the middle? Positive 7x. We can if the 15x is positive and the 8x is negative. So we'll make the 8 negative and the 5 times 3, 15 positive. And we now have factored our expression. By the way, a nice little trick along the way is I knew not to do 4 and 5 because if I had put the 4 in the first factor, off to the side here, we had 2x and 3x. If I had put the 4 in the first factor and the 5 in the second factor, notice that would have given me a GCF of 2 in the first factor. We should never have a GCF inside a factor. So I knew right away that the 4 did not go with the 2 because they're both divisible by 2. The 4 had to go with the 3 because neither one had a common factor. They're only divisible by 1. So that helps me with my guess and check. Let's try a couple of these. Let's do negative 3x cubed plus 12x squared minus 9x. Looking at all three terms, we will notice they do have a GCF. Always do the GCF first. They both have a GCF of negative 3. Why negative? We like the first term to be positive, so we pull out a negative. All three terms also have an x on them, so we'll pull out an x. And we do that, that's left with a positive x squared, a negative 4x, and a positive 3. Now that we've got that GCF of negative 3x out front, now we can start talking about factoring what remains. X squared is probably x times x. 3 is probably 3 times 1. And so we check it on the outside. X times 1 is x. On the inside, 3 times x is 3x. Can we use x and 3x to get negative 4? Yes, if they're both negative. So we'll make them both negative. Negative 3 and negative 1. Notice a negative times a negative is a positive 3, like we want at the end. We have our solution. Let's do another one. How about 5x squared plus 30x plus 45? Again, the first thing we're going to look for is the GCF of 5. Leaves behind x squared plus 6x plus 9. Still with the 5 out front. X squared is probably x times x. 9 is probably 3 times 3. And if we check on the outside, there's 3x. On the inside, there's 3x. And if they're both positive, that'll give us 6x in the middle. And just by way of cleaning this up, you might notice both factors are exactly the same. Because they're the same, we're going to continue to factor them to 5 times x plus 3 squared for our final solution. One more. 15 minus 2x to the n minus x to the 2n. No GCF this time, so we'll go right to our factors. 15 is probably 5 times 3. And x to the 2n, notice if you divide that exponent by 2, you get x to the n times x to the n. Multiplying the outside, we have 5x to the n. Multiplying the inside, we have 3x to the n. We want to end up with negative 2. The way we get negative 2 is we make the 5 negative. So the factor with the 5 was on the outside. negative on the outside, so 5 times negative x to the n is negative 5x to the n, and a positive 3x to the n on the inside, we have now factored our trinomial. So that's the first half with these quadratic expressions and equations. Factoring. GCF first. 2 terms, we use a product, special product. 3 terms, guess and check. 4 terms, we'll use grouping. That's how we factor. And now that we know how to manipulate these equations, I think I'm on F, we're ready to actually solve these equations. And there are actually 4 ways that we go about solving these quadratic expressions, these quadratic equations, I'm sorry. The first way, the most common way, is when possible, we'll use the zero product rule. And the idea of the zero product rule is if 2 things multiplied together equal 0, then one of them has to equal 0. Then A equals 0 or B equals 0. In other words, if we can set it equal to 0 and factor, we can set each factor equal to 0. So if I have 2x cubed minus 2x squared minus 4x equals 0, and we want to know our possibilities for x, first thing we always look for when factoring is the GCF. You'll notice all factors are divisible by 2 and x. That leaves behind x squared minus x minus 2 equal to 0. Continuing to factor the remaining trinomial, we get x minus 2 and x plus 1 using guess and check. Now that it's factored, we've got 3 individual products that equal 0. One of those products then must be 0. So we say either 2x equals 0, x minus 2 equals 0, or x plus 1 equals 0. Solving each of these by dividing by 2, x equals 0, adding 2, x equals 2, and subtracting 1, x equals negative 1, we get our 3 possible solutions for this problem. Let's do another example. Let's do 3x squared plus x equals 2. One thing that we notice is different about this problem is not equal to 0. It's equal to 2. Whenever we're solving an equation that has both x squared and x in it, we need the equation to equal 0 before we can move on. So we'll make it equal to 0 by subtracting 2. That leaves behind 3x squared plus x minus 2 equals 0. And now we can solve by factoring. 3 terms, so we'll use guess and check. 3x squared is probably 3x times x. 2 is probably 2 times 1. And so when we check that on the outside, 3x times 1 is 3x. On the inside, 2 times x is 2x. So if the 2x is negative, the middle part negative, the outside part positive, we would get the 1x in the middle that we want. And then, now that it's factored, we can set each factor equal to 0. 3x minus 2 equals 0, and x plus 1 equals 0. These all solve really quick. The first one we add 2 and divide by 3 to get 2/3. The second one we subtract 1, and we get our second answer of negative 1. Let's try another problem. This problem is one of the easiest problems. 4x squared equals 8x, and it's probably one of the most missed problems because students want to do things like divide by x. We can never divide by a variable because we can never divide by 0, and we don't know if the variable is equal to 0. So we can't divide both sides by a variable. Again, like the last problem, notice we have x squared and x. The way we solve those is we make them equal to 0 by subtracting 8x from both sides, giving us 4x squared minus 8x equals 0. Factoring, first thing we look for is GCFs, and there's a GCF of 4x, leaving behind x minus 2 equals 0. Once it's factored, we set each factor equal to 0. 4x equals 0, and x minus 2 equals 0. Dividing both sides by 4, our first answer is 0. Adding 2 to both sides, our second answer is 2. The reason we couldn't divide by x here is that indeed it turned out that we were dividing by x equals 0, and we can't divide by 0. Whenever there's x squared and x, make the equation equal to 0 and factor. Let's do one last. 25x squared equals 30x minus 9. Again, we want the equation to equal 0. We like x squared to be positive, so let's subtract 30x and add 9 to both sides, keeping the x squared positive, giving us 25x squared minus 30x plus 9 equals 0. Factoring then, 25x squared is probably 5x and 5x. 9 is probably 3 and 3. And if they're both negative, you see we've got 5x minus 3, and 5x minus 3 is going to give us 15x, and 15x is 30x in the middle. Since both factors are the same, we'll write it as 5x minus 3 squared equals 0, which means there's really only one factor that we have to make equal to 0. Solving this equation, we would add 3 and divide by 5. So x is equal to 3/5. And in this problem, we only ended up with one solution of x equals 3/5. So if there's an x squared and an x in the problem, we're probably going to make it equal to 0 and factor. But there's a few other ways we can attack the problem. One way is to extract a square root. We're going to do this when there is no x term, just an x squared term. And what we're going to do is simply get rid of the squared by taking the square root of both sides. So for example, if we have 3x squared equals 18. Before we take the square root of both sides to get rid of that x squared, let's get the squared part alone by dividing both sides by 3, giving us x squared equals 6. Then we can take the square root of both sides because square and square root are inverses, leaving x equals plus or minus the square root of 6. Which brings up an important point. When we take the square root of both sides, we must have a plus or minus in our solution, because squares have two solutions. Square root needs to give us both the positive and the negative potential solution. So if we have x plus 3 squared equals 5, again, notice we can take the square root of both sides to clear the squared. Leaves us with x plus 3 equals plus or minus the square root of 5. We're not done yet, though, because x is not alone. We still need to subtract 3 from both sides. So we get x is equal to negative 3 plus or minus the square root of 5. And this becomes our final solution. Extracting square roots leads to the completing the square, which we'll get into more detail in a future lesson. Completing the square, though, leads to, you might remember, everybody's favorite formula from pre-college math, the quadratic formula. Which you should have memorized. If you don't have it memorized yet, memorize it now. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. This is an important formula for you to have memorized in this class and your future math classes as well. The nice part about the quadratic formula is every problem simplifies the exact same way. So we only need to do one example. Let's do 2x squared plus 5x minus 11 equals 0. Again, it has to equal 0, and the advantage of the quadratic formula is we're going to use it when we can't factor. If we were to try to factor this, we would find nothing that worked, that gave us that 5 in the middle. Feels like a dead end until we use the quadratic formula. 2 is a, 5 is b, negative 11 is c, so x is equal to the opposite of b, negative 5, plus or minus the square root of b squared, 5 squared, minus 4a, which is 2, c, which is negative 11, all over 2a, which is 2. And then we simplify. 5 squared is 25. Notice the two negatives. A negative times a negative is going to make a positive. 4 times 2 is 8, times 11 is 88. Over 2 times 2 is 4. So x is equal to negative 5 plus or minus the square root of 88 plus 25 is 113 over 4. And that is our final solution. So those are kind of the ways we can solve an equation, by either factoring, extracting a square root, or the quadratic formula. I want to look at one other type of problem, though, that's going to become very important to us in this class, is when a problem is quadratic in form. So if you've been spacing out up to this point because it feels like review, time to wake up. This is the important new stuff that builds on this review. We're going to have stuff that's quadratic in form, and the trick is we want you to see the stuff as the variable. So to set up a simple example first, if we've got x to the 4th minus 26x squared plus 25 equals 0. Notice the x squared is in the middle instead of a regular x. If we think about the x fourth as x squared squared, we've got stuff squared minus 26 times stuff plus 25 equals 0. Well, we can factor this. X to the 4th is probably x squared times x squared. 25 is probably 5 times 5, but when we test that out, what we'll find is that's going to give us 10 in the middle, not 26. So we need a different guess. The only other way to get 25 is 25 times 1. And if they're both negative, that will give us negative 26x squared in the middle. But this actually factors further. X squared minus 25 is a difference of squares. X plus 5, x minus 5. And x squared minus 1 is also a difference of squared. X plus 1, x minus 1. So now we can set each factor equal to 0. X plus 5 equals 0, x minus 5 equals 0, x plus 1 equals 0, x minus 1 equals 0. And solve each equations to get solutions of negative 5, 5, negative 1, and 1. That one we probably could have done before, though, just stretching that x to the 4th is x squared times x squared. Let's try a more interesting problem. Let's do 6x to the 2/3 minus 5x to the 1/3 minus 4 equals 0. We can still factor this. X to the 2/3 can be split into two parts, x to the 1/3 and x to the 1/3. So 6 is probably 2x to the 1/3 times 3x to the 1/3. 4 could be 2 and 2, but if we did 2 and 2, we would have a GCF in the left factor, so 2 and 2 is not going to work. So it's probably 4 and 1, and the 4 can't go with the 2, so I'm going to go 4 and 1 on the outside. See what that gives me. 2 times 4 is 8x to the 1/3. 3 times 1 is 3x to the 1/3. If the 8 was negative, negative 8 plus 3 would be that negative 5. So I'm going to make the 8 negative. That was the 2 times 4. Let's go ahead and make it blue. And the 1 positive. Now we can set each factor equal to 0. 2x to the 1/3 plus 1 equals 0. And 3x to the 1/3 minus 4 equals 0. Solving the first one, we get x to the 1/3 equals negative 1/2. The way we get rid of a 1/3 is we do the reciprocal exponent, the third power. So x is equal to negative 1 cubed is negative 1 over 2 cubed is 8. Our first answer is x equals negative 1/8. The second answer, for the x to the 1/3, we will add 4 and divide by 3. And then we get rid of the 1/3 power with the reciprocal 3 power. And so x is equal to 4 cubed is 64 over 3 cubed is 27. And we have our next solution. Let's look at some more interesting problems. How about x plus 1 over x plus 3 squared plus x plus 1 over x plus 3 equals 6. What we're going to do is we're going to treat the stuff as its one ugly looking variable. That stuff is going to stay together. First, though, it has to equal 0. So we'll subtract 6 from both sides. X plus 1 over x plus 3 squared plus x plus 1 over x plus 3 minus 6 equals 0. To factor it then, the stuff squared is probably the stuff times the stuff. X plus 1 over x plus 3 times x plus 1 over x plus 3. The negative 6 is probably 2 times 3. And if we make the 3 positive and the 2 negative, that'll give us 1 stuff in the middle. So we make each factor equal to 0. X plus 1 over x plus 3 minus 2 equals 0. And the stuff, x plus 1 over x plus 3 plus 3 equals 0. Solving is going to take a little bit more work here, but we can do that. Add 2 to the first one to get x plus 1 over x plus 3 equals 2. And now that the fraction is alone, we can clear the fraction by multiplying both sides by x plus 3. Leaving behind x plus 1 equals, distribute the 2, 2x plus 6. Subtract x from both sides and subtract 6 from both sides. We get negative 5 equals 1x for our first solution. Second equation, solving the exact same way. This time we're going to subtract 3 equals to a negative 3. And then we can multiply both sides by the denominator of x plus 3, because that denominator will divide out, leaving x plus 1 equals Distributing the negative 3, negative 3x minus 9. Now we add 3x to both sides, subtract 1, getting all 4x's on one side and negative 10 on the other side. And when we divide by 4, x is equal to negative 5 halves for our second solution. So if we can recognize the problem as being quadratic in form, treating the stuff as the variable, it can factor and solve just like all the other stuff we've seen. So the homework assignment in the textbook takes a look at factoring, takes a look at solving by either zero product rule, extracting square roots, quadratic formula, possibly quadratic in form. Take a look at it, give it a good practice, and we will see you in class.